In order to protect ourselves and our research facilities from potential dangers, it is important that we adhere to biosafety and biosecurity practices. Biosafety deals with the containment and safe handling of dangerous biological substances including infectious microorganisms. This pertains to how we manage COVID-19 and other public health crises as well as how we treat animals, plants, cell cultures, bacteria, viruses, fungi, and parasites. The principles of containment and risk assessment are used in biosafety to reduce or eliminate the exposure of lab workers, the local population, and the environment to potentially infectious or dangerous substances. Biosecurity is characterized as a strategic method for assessing and controlling hazards to the environment, animal and plant life, and human health. It is founded on the understanding that risks have the potential to be intentionally or unintentionally misused, leading to harm. Laboratory biosecurity, specifically, is a set of procedures and policies used in research facilities to safeguard microbial agents against misappropriation, theft, diversion, and loss. There are many similarities between biosafety and biosecurity, but they are not the same. Various levels of laboratory controls and containment, access controls, personnel knowledge, the use of specialized containment tools, such as biosafety cabinets, and established operating procedures are all used to achieve biosafety. Biosecurity is accomplished by limiting access to the research facility, research materials, and information associated with that agent and/or research. Types of biosafety cabinet. Biosafety Cabinet Class 1. A Class 1 cabinet is defined as a ventilated cabinet for personnel and environmental protection. Class I cabinets do not offer product protection from contamination, limiting their use in some life science applications. Class 1 BASTs pull room air through the front, away from the operator, and have a similar airflow pattern to a fume hood, but they also have a HEPA filter at the exhaust outlet. They may or may not be ducted outside. Class I cabinets are safe for use with agents requiring biosafety level 1, 2, 3, or 4 containment. A Class 2 cabinet is defined as a ventilated cabinet for personnel, product, and environmental protection for microbiological work or sterile pharmacy compounding. In laboratories, these hoods are often referred to as cell culture or tissue culture hoods. In pharmacy settings, these hoods are often referred to as chemo hoods. Class 2 BASTs are designed with an open front with inward airflow, personnel protection, downward HEPA-filtered laminar airflow, product protection, and HEPA-filtered exhaust air, environmental protection. These cabinets are further differentiated by types based on construction, airflow, and how they interface with exhaust systems. The types include A1 and A2. All Class 2 BASTs require all biologically contaminated ducts and plenums to be under negative pressure or surrounded by negative pressure ducts and plenums. Type B2 cabinets take this a step further, requiring all biologically contaminated ducts and plenums to be under negative pressure or surrounded by directly exhausted negative pressure ducts and plenums. Type C1 cabinets provide additional safety by maintaining protection from biological and chemical hazards during building exhaust failure. Like Class 1 cabinets, Class 2 cabinets are safe for work using agents requiring biosafety level 1, 2, 3, or 4 containment. Type A1 and Type A2 biosafety class cabinet. A Class 2, Type A1 cabinet must maintain a minimum average inflow velocity of 75 fpm through the sash opening. They may exhaust HEPA-filtered air back into the lab or maybe exhaust outside using a canopy connection. They are suitable for work using biological agents without volatile toxic chemicals and volatile radionuclides. Type A1 cabinets have overwhelmingly been replaced by Type A2 cabinets over the last few decades. A Class 2, Type A2 cabinet must maintain a minimum average inflow velocity of 100 fpm through the sash opening. Like Type A1 cabinets, they may exhaust HEPA-filtered air back into the laboratory or may be exhausted outside using a canopy connection when handling odorous samples or minute quantities of chemicals. They may also be used with tracer quantities of radionuclides that won't interfere with the work if recirculated in the downflow air. Type A2 BASTs are the most common Class 2 cabinet. And lastly, the Class 3 cabinet is defined as a totally enclosed, ventilated cabinet with leak-type construction and attached rubber gloves for performing operations in the cabinet. The cabinet has a transfer chamber with interlocked doors that allow for the sterilization of materials before entering/exiting the glove box. The cabinet is maintained under negative pressure and supply air is drawn in through HEPA filters. The exhaust air is treated with either double HEPA filtration or single HEPA filtration followed by incineration. Class 3 cabinets are safe for work requiring Biosafety Level 1, 2, 3, or 4 containment.